Hi everybody, this is a video on solving systems of equations using elimination. So elimination is a method of combining two linear equations, and we most often do this for standard form equations. So first I'll just show you how this works, and I think that'll help see why we might do this. So I'm going to add these two equations together. When I add negative x and positive x, I get 0. When I add 2y and 6y, I get 8y. And when I add negative 8 and negative 16, I get negative 24. So, just by adding these two equations together, I don't have any x anymore, and I can solve for y immediately. So this is called elimination because all of a sudden x is gone. Now I continue on solving like I would any other equation, but I get my first variable quite easily. So just by doing this that quickly, I get y equals negative 3. I'm going to write that into my solution. Now, how would I figure out what x is? Well, I go back to whichever equation I think looks simplest. For me, that's the bottom one. And I rewrite it. But this time, instead of using y, I use negative 3. So x minus 18 equals negative 16. X equals 2. Oh, there's my solution. That's a pretty easy process. So it helps me find my y first in this case, and then my x. Let's take a look at another example. So example 2 here, I see that I have negative 3y and positive 3y. If I add those together, they will eliminate, they will cancel. I will have no y's left. So 2x plus 4x is 6x, and 8 plus 16 is 24. So with very little work, I can figure out that 6x equals 24, or that x equals 4. Now this part is a little bit harder. I need to figure out what y is. So I'm going to go back to whichever equation looks easiest. And I think that is the second equation. So 4 times the 4 I found for x plus 3y equals 16. Or 16 plus 3y equals 16. Now there's only one thing I can add to 16 and stay at 16, and that's 0. So 3y must be 0, and y must be 0. So moving on to problem 3, I have a little bit of a problem. And that is my x's don't match up, and my y's don't match up. So I have to use a little bit of algebra here. I notice that I have positive 3y and negative 6y. And those are very close to being the same thing. So I'm going to double my top equation, like this. And that's going to give me 4x plus 6y equals 6. Now, my y variable eliminates. I have negative 6y on top and positive 6y on the bottom. When I add those together, I get 5x plus no y's equals 0. Now, this doesn't mean you got the wrong answer. If 5x equals 0, then x equals 0. So I go back to whichever of these 3 equations looks easiest. I'm going to go with the very first one. And I'm going to say 2 times 0 plus 3y equals 3. So that's 3y equals 3, which means y equals 1. So my solution for that one is 0, 1. Okay. So in this problem, I don't have x and y on the same side. I don't have a standard form equation. So some people might want to solve this using substitution, but let's practice elimination for just a second. So in order to make these line up, I have to move my y to the other side of the equal sign. And the only way to do that is to subtract 2y from both sides. So that's x minus 2y equals 12. Now, my variables are in the right place, but my coefficients don't match up. So it really would be nice to have a positive 2y and a negative 2y. So I'm going to double my top equation. Negative 6x plus 2y equals negative 2. Now when I add these together, I'm going to get negative 5x, my y's cancel out, equals 10. This means that x equals negative 2. So I'm going to go back to one of my equations. It doesn't matter which one, but I think this one is easiest, and fill in that x value. So I get 6 plus y equals negative 1. When I subtract 6 from both sides, I get y equals negative 7. So my answer is negative 2, negative 7.